This is a video from the Chapter 6 review. We're going to take a look at problem 5. It says, find the volume of the solid obtained by rotating the region bounded by the curves, in this case x equals 1 plus y squared and y equals x minus 3, about the y-axis. Okay, and so this is the region that we're dealing with, is right here. So you notice we're going to rotate this region about the y-axis. Now, I'm going to draw my rectangles going this way, horizontally. So notice my rectangle in red here. And so I want to apply the washer method. But in order to do that, we need to have an outer radius, we need to have an inner radius, and then we need to have our limits of integration. So if we look here, the outer radius is going to go from the line in blue here, right, out to the y-axis. The inner radius is going to go from the parabola out to the outer to the y-axis, like so. So now, notice if y equals x minus 3, we can say that x equals y plus 3, right? So the outer radius is going to be y plus 3. The inner radius is 1 plus y squared. Now, the question is, where do these graphs meet? What are the values of y where these graphs meet? So I'm going to set y plus 3 equal to 1 plus y squared. So I'm going to subtract y, subtract 3, subtract y, subtract 3. And then I get y squared minus y minus 2 equals 0. So if I factor, I get y minus 2 times y plus 1 equals 0. So it says y is 2 or y is negative 1. And so notice here that seems to be reasonable, right? According to the graph. Now we're ready to set up our integral. So we got a volume. It's going to be pi times the integral from negative 1 up to 2. The outer radius is y plus 3. So I'm going to take y plus 3 and square it, minus the inner radius, which is 1 plus y squared. And I'm going to take that and square it. And so I'm going to take that and then integrate with respect to y. So this is pi times the integral from negative 1 to 2 of. And I'm going to get y squared plus 6y plus 9 minus y to the 4th plus 2y squared plus 1. So I just squared out everything. And I'm integrating with respect to y. So this is pi times the integral from negative 1 to 2 of. Now, 9 minus 1 is 8. So I'm going to cross off the 9 and the 1. Y squared minus 2y squared is minus y squared. So I'm going to cross these two terms off. I'm going to add 6y and then subtract y to the fourth. And that whole thing is getting integrated with respect to y. So this is pi times the quantity, 8y minus 1/3 y cubed plus 3y squared minus 1/5 y to the fifth. And again, this is evaluated from -1 up to 2. Let's pop the 2 in. So this is pi times. Now, if I put in 2, I get 16 minus 8/3 plus 12 so far, right? 16 minus 8/3 plus 12. And then when I plug in 2 here, I get minus 32/5. And then I'm going to go minus. And then I'm going to plug in -1, and I'm going to get -8 plus 1/3 plus 3 so far, right? I just plugged in -1 for y. And then when I plug in -1 over here for that last term, I get plus 1/5. And we have a calculator, so, however you guys want to do it, right? So if I take 16 and 12, I get 28. If I get -8 plus 3, I get -5. So I'm taking 28 and then subtracting -5. And so 28 minus a -5 is 33. And then what I do, like a grocery list, I cross off the 16, cross off the 12, cross off the -8 and the 3. If I take -8 and I subtract -1/3, I get -9/3. But -9/3 is equal to -3. So I subtract off 3. So I cross off these two numbers here. And then I'm going to take -32 over 5 and subtract off 1/5. And I get minus 33 over 5. And so this is pi times 30 minus 33 over 5. But remember, 30 is the same as 150 over 5. And if I take 150 and subtract off 33, well, that's 117, right? And so here we should get 117 pi divided by 5. And that'll conclude this video for the Chapter 6 review, and we worked on problem number 5. Thank you.